I'm a Fluent Bit contributor working here at Chronosphere. And today we're going to talk about parsing, about what we look for when we do parse of our data. This is the agenda. Briefly, we will do some very short intro today to Fluent Bit. We assume most of you know what Fluent Bit is or have worked with Fluent Bit, and then we'll talk about these logging challenges where parsing help us, and then demos. Yeah, we will do a couple demos trying to cover the most basic, and also one particular topic that it seems the community wants to talk about, which is the multiline parsers. And finally, just a few recommendations when doing parsing, and how to also look for help. Okay, so do not skip the intro. We are used to skip intros if you like to watch streaming services, right? We will not do that, but it will be brief, I promise. So Fluent Bit is a CNCF graduated project. It means that it passed stages that the foundation put into place for the projects, and to ensure that the graduated project are mature enough to be used in production environment. So Fluent Bit is the second project of the Fluent family, and it's graduated as well as its original project Fluent. This webinar is focused on Fluent Bit. This is a full telemetry agent, meaning that we can process and we can ship logs, metrics, and traces. Today, we're going to focus in the logs part of this. Okay, so let's talk a bit about the logging challenges. These are some slides that Eduardo prepared. Probably you saw on a previous presentation we did in KubeCon North America last year. And we're going to talk a little bit about this. So thanks, Eduardo. I borrowed these slides. So let's go with this. So what is the end user goal that we are trying to help to solve? They want to do data analysis, right? And why they want this? Because they need to transform all this data that you have in the logs into meaningful information. And this information will help you to take technical and business decisions, right? The logs will not only tell you when the software is not behaving as expected, but also will give you insight of your business. You can get from the logs how many users are using one part of your software, for example, or let's think on banking software. You can tell, for example, how many users are completing money transfers, or how many of them are not completing money transfers, and from those, how many are not completing them because they are seeing errors, right? So that's the end user goal. They need to analyze this data, and for this, we need to bake this data, right? So how are we going to provide this meaningful information to the end user? First of all, by collecting the information from the services and applications that we have deployed. All our systems, or most of them, will generate useful information about the behavior of the software, about the errors, or even on what it's doing, right? A user was able to log in, a user was able to visit this section of the website. A user was able to complete this this information. A user was able to or wasn't able to do certain operations in your website, right? So the logs will tell us what's going on with our application if, of course, the developers set up this right. And all this data will be written to the logs, right? That's our main source, and it's our focus of the webinar today. Well, what are the challenges here with the logs? That there are a lot of sources of your data. It's not only the log from your application, but it's also the logs from your, in this example, from your HTTP server, which is Nginx, from your system through syslog, and other platforms as well. The data can come from your Linux boxes or your Windows machines, and you need somehow to collect all these different sources of data, and you need to give them value or extract the value from them, right? So where are the logs? The logs can come from your file system, right? Or devices, can come from API services, can come from network endpoints, right? So it's not only the kind of log that we have, but also the different sources that we have. And once you collect this, the end user needs to see the value on this information, this data, right? They will not take a lot of this if the data is in the format that we saw before, right? If they see lines without meaning for them, that's not gonna work. So they need this data to be processed, right? This is the expectation of the end user. And in reality, right, you have this amount of sources, and then you need to start collecting these logs. You need to start further processing and enrich the logs, etc., and provide finally something that is visually attractive, but at the same time is really meaningful for the end users. There is a question here. Okay, we have a couple samples. Joshua is asking, will the session also go through filtering in order to reduce noise or unnecessary logs? Yeah, in one of the examples, we could use one filter to demonstrate that. The focus today is why we are parsing, what kind of parsers we have, but we can certainly include that in the demo. Thanks for your question, Joshua. Okay, so this is one of the realities that we face when we are looking into the logs. The first line that you see here, probably for most of you is quite clear what it's saying, right? You can tell what is here just by looking at. But for the users, this is not useful, right? So what we need to do is, okay, let's identify what is in this line and convert this unstructured log line into a structured log, right? We know that the first 4 numbers separated by dots, those are an IP address, right? Then we can identify that we have a request time there. We have the date, we have the time, and we have the time zone, right? That's something that we can tell. And the HTTP method, the URL, the HTTP version, status code, content size, user agent, right? That's data that we can identify, but it's not really useful for the end user. So what we need to do is to parse this line of log, right? We need to extract that data and put them into something that other applications or even other kind of users can read easily, right? So this unstructured log will transform from this line at the top to this other structure, which in this case is represented as a JSON structure, right? So this is more useful than the line above, right? And for some systems, it will be easier to deal with this than to deal with the line above, right? So this is what parsing is: transforming unstructured data into structured data for further processing. Okay, so this is where parsing is gonna help us. And another part of the reality of the logging challenges, and this is related to Joshua's question. From these many sources that we have, we could be tempted to, hey, let's take all the data that we have, let's take all the logs that we receive and send them to a system where we can further process, right? And this is usually the first approach that people will take, but this certainly will not scale, and it will not be friendly enough with your wallet as well, right? We know that a lot of vendors will charge for storage, right? So as Joshua was asking for, can we remove these unnecessary logs or even unnecessary parts of the logs? Yeah, that's something that we can do with parsing as well, or that we can do after parsing, depending on the case, right? So these are the challenges that we have in the logging part of observability. And this is in particular where parsing is going to help us, right? So as a summary of the challenges, we need to do data analysis, right? But to do that, we first need to gather the data from all your sources. And then all these different structures of the data that you are collecting should be converted into common or easily handling data structures, right? It's better to have a JSON format instead of only plain text, right? And for that, we need the parsing, okay? So with that, we're going to move to the first examples here. Let me quickly check if there's any other question. Oh, someone is raising a hand. Okay, no. Okay. So what we have here is a Apache common log excerpt. So if we want to read this, we could easily do this by using the YAML, the tail input plugin, right? So we are gonna define our pipeline. We will say that our input, by the way, this is the YAML configuration format. Probably some of you are used to the classic format. We still support both of them, but we are encouraging the use of YAML, there are some improvements over in Fluent Bit that are not supported into classic format. So yeah, let's move to YAML if possible. So this is going to be tail. The path is going to be here, but in the log samples, Apache common log, right? And we have a default value for the refresh interval of 60 seconds. That is not ideal, even more for these live demos, but we can easily change it to 1 second. And we have inputs, and then the output that we usually recommend for troubleshooting and for learning purposes is, of course, our love standard out. And you see to match everything, right? Okay, so for now, we should be good to go. And we're going to Apache. Apache common. Yep. Okay, so woohoo. Outputs. Yep. Okay. So what we are telling here to Fluent Bit is that we're going to use the tail plugin. This is the log file that you're going to read. You're going to check for files every second, and anything you get from here, you're going to write to standard out, right? On this case, it's not reading the content because the data is already there. We're going to tell it to read from head, so I will read from the beginning of the file. And okay, so what we have here is that Fluent Bit has read all the content of the file, but as you can see, this is a single line that is not very useful, right? This is not something that we can ingest in our systems to further extract valuable information from here. So this is a common log format, and we have with Fluent Bit, we ship several parsers already. And one of those is this, the Apache parser. This is the regular expression that is going to extract the data from here. So what we are going to do is to include this parsers file into our configuration. Okay, so this is in the service section. Parsers file, parsers conf. Okay, and we're going to tell Fluent Bit to also parse this using the Apache parser, right? So let's go. And now when we run it again, okay, Apache, okay. So now we should be able to see what happens when we add a new line to that. So we're going to add a new line to that file. Let's see what happens. Okay. Why is nothing happening? I added a new line. Let's do it again. Bear with me. Okay, I'm just going to tell it to read from head. I'm not sure what's going on, but let's run it again. Reading from head. Okay, so now we can see that instead of sending only one record called log, right? Log and with all the content here, we can see that it actually parsed the data and it extracted the host, right? Host, the user, and so on, right? So it was able to extract these fields from the data that we are presenting here. Okay. Okay. So this is what we will do for the common formats. As I mentioned before, uh, we have a lot of parsers built in and shipped with Fluent Bit. So all these parsers you will be able to use. They are not only um, for the Apache, but also Nginx, uh, Nginx running Kubernetes. We also have Parser for JSON. We have Docker, CRI, etc. You can look into the list if you want. Okay, so another part of the parsing is when we need to parse different sources where um, where the data that we are collecting um, will have not only a single line, but it will also have multi-line, right? So we could use here. So in this case, this was taken from an issue report that we received on GitHub. So in this case, this is a very long Java exception that needs to be parsed and needs to be sent in one record only, right? This is one unit of log. Even though it is printed in several lines, it's only one event of log, one log event. So for that, we also have the multi-line parsers. Previously, in Fluent Bit, we had one way of configuring multi-line parsers where we will tell, hey, this is the first line of the parser. This is the, when you identify this first line, it means that a multi-line log event begins, and it will collect the rest of the data based in a regular expression that is or that was also defined there. Now we have a different multi-line parser. It's a bit different, and with this new multi-line definition, we also provide some built-in multi-line parsers. We provide the multi-line parser for Docker, for CRI, for Go, Python, and Java. These are built-in. You only have to configure to have them to work. But there are some cases where this is not good enough, and here's where the custom multi-line parser comes into play. Basically, the new multi-line engine is a state machine. So you will tell what the first line is, or the first state in this case, and then you tell what kind of new lines you can have. Okay, what will be in the next lines in this multi-line structure log. So for that, let me grab configuration. Multi-line. Okay, so this one should be pretty much the same, but we're going to take the Java. Okay, this parser is not Apache anymore. Okay, what happens when we read from this file? So what happened is that, right, every single line from this log file seems to be a different log event, right? There's no parsing here at all. So for this, we can include a multi-line parser. This is the new multi-line parser engine. And we're going to add the parsers. We have fine. Set file. Okay. So here we have a definition for a multi-line nested. This is the same configuration we provided through GitHub. So basically, we are saying, hey, whenever this is the start state, whenever you find a line that contains the colon exception or error, trouble, etc., okay, and the end of the line, you move to the next state, which is Java after exception, all of this, right? So there you can have lines saying nest exception or empty lines or etc. or here tabs and etc. These are all the matches that could occur after that. But there is also a special state that is called nest exception. So if we find a line that says a nest exception is, which is here, right? It means that is part of the same record. Right. So this is a special case of multi-line parser that we can configure and have Fluent Bit to use it. So this is called multi-line nest. Okay. Let's see. Not register. Yeah, because the file is multi-line parsers. Okay. So now the Fluent Bit was able, through this new parser definition, to say, hey, this text from here, it's only one log event, right? So it will have the main exception there, and then the caused by exception. And then it will also capture this exception here with the nest exception, right? It will be able to capture all the lines there, which are coming into separate lines originally, but it will collect them all as single log events. Recently, we also see from some users that were using Spring, and sorry for monopolizing this with Java, but it's from recent examples that we have seen. So this is a Spring app, and apparently the format, the default login format changed. So they could not use the previous parsers that they were using. And for these, we will usually use regular as our regular expressions engine helper. We use the Ruby regular expressions engine in both Fluent D and Fluent Bit, and this website will help us with that. So we will use regular to test our regular expression against the samples that we have. So we're going to define a parser for this. So let's get into it. Let's do another config. Spring up. Now let's keep the same name. It should be again almost the same, but it's spring up.log, right? And of course, this is not the parser we want to use. Okay, so let's see what it does with the default. Again, we should see, yeah, every line treated as a different log event. And yeah, that's exactly that we have. So we even see the banner here processed as a regular log event. We can get rid of it and to show for Joshua's question. Wait a second, there is a question. What happens when a question from Kylan. What happens when the multi-line inputs change in length or wording? Do you just need to add those rules to capture the different types of event that might occur? Any dynamic way to go about this? Yeah, exactly that, Kylan. So in the Java nested, there was a change here where they were only, in the first place, they were seeing like standard Java stack traces where there were non-nest exceptions. I don't know why it took longer to see nest exception in their logs, but that was the case, right? So they were trying to use the built-in Java parser for this. And the built-in Java parser does not include the case of the nest exception. So once it got here, it will treat this as a different log event because it didn't know that the nest exception line was saying, hey, this is part of the same log event. Sorry. So that's why we went to the original parser that they have, and we added this. We added one line and modify another. So we said, now, whenever you find the nest exception string there, move to a different state, which is Java nest exception. And we know from the log sample that after that line, we will see another exception, right? Another line containing the word exception inside. Because the original parser was saying, hey, if I see exception there, this is a new log event. This is the start state, right? This is a new log event. So in order for the parser to ignore that and say, hey, no, this is the same log event, we capture this occurrence and we move it to a different state, to this next exception. And once we read the second line there, and I mean this as the second line, we said, okay, now you're back to normal. You're back to the state Java after exception. Is that clear, Kylan and others? I hope it is. Okay. There is another question here. Hamid, sorry if I'm not pronouncing this well, says, in a scenario, I need to first use filter with grep module. Then I must use parser to parse my log. Would you please show this scenario too? Okay, we will do that. This is quite similar to Joshua's question. We will do that. We will use this banner and the processing of this example to demonstrate that, Hamid. If I do not demonstrate that during the next demo, just let me know and we can retry, okay? Okay, so this is where we are now. We have these Spring App logs, and yeah, there's no format here, right? So we need to create a parser that can extract the data from this line. So I made this in advance. So I'm going just to copy and paste here in Parsers. To the bottom of them. And this is called Spring, right? Quite original, but okay. So what we're going to do is to show ruler. Let's do this here. So first of all, I'm going to, copy one log sample. Okay. So let's say this one. And I'm going to paste it here. And then my regular expression is here. Okay, so you can use ruler to start defining your regular expression. So let's say that we don't have this, okay? I'm going to grab another line from here because there is one difference that we can use. Okay, so let's say that we started doing the regular expression for this, right? So we have the time capture, and now we say that there is one space, and then it comes the level, and then the process ID, etc. Right? So okay, this seems to work with the debug level that we see here. Ravi is saying Genai is better for regex validation. Is that a web application? Is something that we can see online, Ravi? No, I don't know what it is, but okay. Oh, artificial intelligence. Okay, I see. Yeah, good idea, of course. Yeah. Yeah, if you don't want to deal with writing your own regex, that's probably a very good idea. And then you can refine the regular expression. Like in this example, where for the debug level, we have one space, but for info, we have 2, right? So probably in our first approach, we could have said, hey, I have 2 spaces here and then debug or whatever, but it was wrong. So you can use ruler to troubleshoot your regular expressions and then implement the necessary changes. So here basically we're saying, hey, I'm expecting 1 space or more, and then the level, right? So now we have a match here. Okay, so that for ruler, and thanks Ravi for the hint on Genai. Was it the same? Oh no, it's another one. Okay, sorry for that. Yeah, if you have the link you want to share, you can share it through the chat and I can send that over to the rest of the fellas in the audience. Okay, so we're going to apply that parser to this configuration, to the Spring App configuration, right? And we're going to say, hey, use the Spring parser for this, okay? Let's see. Okay, now we're talking. Now we see that we have the time, we have the level, process ID, the app, etc. Right? And this is meaningful information. But as Joshua was pointing out, and similar to, no, I think it was just Joshua. Yeah. So these lines here, yeah, there's no use of these lines, right? Probably this one to know the Spring Boot version used, but the rest of them, I don't think so. Okay, so what we can do to help on this, because we don't like this one, right? We don't like these lines going through our backend. So what we can do here is that we can add a filter. Just a second. Filters, okay. I think I should have it here. If not, okay, anyways, so we can add the filter here. Filters, and we can parser. No, this is grep. We already parsed this, so grep, and then match everything. And we will say that if we have the level field populated with anything, right? It means it is a valid log event, right? Okay. Yeah. So we started with these log records, right? These log events where the data is unstructured. If you look into this, you will probably easily spot what is here, right? But this is not useful for machines. So we need to parse the data. We need to convert this into this. And we can also get rid of unnecessary data here. We can get rid of the banner log events, right? We can get rid of 10 lines out of 26. So yeah, over 30% reduction for this case, right? I don't think it's a real number for this particular thing that we did, but yeah, let's say that the one developer or one production engineer forgot to turn off the debug levels. So your application is producing a massive amount of log. Yeah, you can configure Fluent Bit to only let go the info and other levels, or you can remove the debug level from the data that you are sending out, right? Yeah. Okay. Okay. No more questions here. Good. Okay. There is another example, another issue that we have seen in the community, which is what happened when my application, let's say that this is a Java application, or when my Apache is running in a container, whether it is Docker, CRI container, what should I do to deal with that, right? So for that, what we can do is to in the first place, to add the CRI parser, and then to add the rest of the parsers that we need to parse our data. CRI will have at the beginning of every line, we'll have the timestamp, the output file for standard out or other. And yeah, let me grab a couple examples here. Yeah, for example, a spring up with coming from CRI, we'll have all these at the beginning, right? So you have to get rid of that first and then apply the rest of the parsers. Here's another question coming from Christoph. It's possible to configure Spring to log in JSON format. Yeah. Can we configure Fluent Bit to parse that directly into a structured log? The JSON format, you mean? Yeah. The log coming in JSON format is one format that Fluent Bit can parse. For that, you will use the built-in JSON parser. This one being built-in parser, you only will have to configure the time key and the time format, and it will extract all the fields from the JSON log event and convert into a structured log. By the way, this here is a representation of the message pack format. This is not actually a JSON, but we can tell, if you want to, we can tell Fluent Bit to actually show the JSON representation of that. We can say here format JSON. You can run that. Yeah, it looks ugly, but Q. Yeah, then yeah, that looks way better, right? For us and for a machine. Leap years XML format. Okay, good question. XML is not supported built-in. Unfortunately, we don't have that. What we will usually recommend that is to use Lua filters. Lua will have XML libs to process that. Unfortunately, this is not something yet available, but as you know, this is an open source, so PRs are always welcome. Microsoft seems to love XML. Yes, they do. Yeah, they have, I think, mostly two formats. One is the non-friendly format of their Windows events, and then XML. I'm not saying it's not friendly, but yeah, it is what it is. There are a lot of other formats, like even YAML, yet another markup language, right? So yeah, yeah. Sorry for that, Lee. Okay, what else do we have? Any other questions? There's another. Hamid, I still have a misunderstanding. That filters come first or parser? In your demo, first grep filter, apply, then parser? Yeah, okay. So um, you can filter first or after doing the parsing, but it will depend in your particular case. On this case, what we are doing is that we parse this data, and then we are grepping the records that do not have the level um, field inside. Would you please do vice versa? Uh, I think, yeah, we could do that. Let's do that. We will usually do the parsing first. That's one of the reasons that we have tail. We have the parsers in the tail plugin, but I think we should be able to do that. Let's use this same, and let's say use the config. Um, let's not parse this. Let's apply the filter, and let's say that the log should have info. And without format. Yeah. So as you can see, we are saying, hey, in the log field, which is the default key or field for the log inside Fluent Bit, it must have info inside, right? Otherwise, I will grab. So we are doing that. And now we can, we can add a parser after that, match everything, and parser is Spain. Yeah, I could be wrong, but yeah. Key name. Key name. I haven't used that, so I could be wrong. If I'm not correct, then we will check the documentation. Because who reads the manuals, right? Okay. Okay. So let's add the format. And let's add JQ. And now we should only see level info, right? So yeah, there you go, Hamid. Yeah, you're welcome. Good. Another question from Kylan. Is there a performance delta in using all custom Lua as the parser plus filters versus using the parcel files with the specific parsers plus filters? And so, yeah, thanks for joining, Kylan. We have interacted before. Well, yes, actually, a long time ago, well, couple of years, which is a lot of time in the observability space, we did some benchmarking with one of the very known cloud providers. They were and they are using Fluent Bit inside their agent. And yes, what we did was that we had, I can't remember the number, but I think it was 15 parsers, one after the other. And then we replaced that. When I say we, I mean together, right? We replaced the filters by only one Lua filter. And the Lua filter showed better performance than having all the filters chained. And this is mostly because of how Fluent Bit works internally. In Fluent Bit, we use a binary representation that is handled by the message pack library, and hence the message pack format, where we will serialize and deserialize every time that we need to process a chunk of data. So for the 15 filters, we were unpacking message pack. We were doing what we need to do with that, and then packing again into the message pack format. And for the next filter, the same. So the performance penalty was basically there in the serialization and deserialization of that data. Now we are in the process of changing these internals of Fluent Bit. It is still message pack, but there are some changes there that are not, I think, not completely done yet, but there are some changes in there. And the other part that is interesting is that now we have the processors that is only supported in YAML format configuration, where you can chain different processors for the same set of logs, for example, and all of them will work with the same unpacked data. So it will go into the processors, it will unpack, it will apply every filter on the list or every processor in the list, and then pack them back again into the message pack format. So there's an improvement there. And if of course, the tail is running threaded, then it will run in another thread, so even better. Okay, I hope I answered your questions, guys. Any other questions? Okay. It seems we don't have other questions. Okay. Oh, we are top of the hour already. Okay, so a couple of recommendations. Heavy process. You saw what we did here, right? We started with looking into how Fluent Bit is receiving the raw data and printing that out, right? And then started looking into the built-in parsers. The built-in parser will cover most of your use cases, so use them. And if you have issues with that, you can always have your own parsers, as we did with the Spring application, right? I left out an example of Spring application, but if you have the issue, it is when you print an exception in the new versions of Spring Boot, it will print an empty line and then the rest of the stack trace. There is a parser already for that. I think we can publish that. But have a process. Start from looking into your data, know your data, and yeah, take it from there. Use the tooling. I showed Rubular. Our friend Ravi mentioned Genai, which I don't know, to be honest. So you can use that as well. ChatGPT is part of the AI tooling that is out there. Test Lab, if you have, it should be easy enough to use Docker container images to test your configuration so you don't mess up with your system. And if still you need help, some recommendations on that, on getting help. Remember that we are an open source project. There's a lot of people using it. Last time we checked, the pull from the Docker Hub was in 14.8 billion pulls from there. So we expect that a lot of users are dealing with Fluent Bit. So try to have a repro of your scenario. Try to parse the data first, right? Do the minimal required config for that. Probably you have a huge config that you don't want to share because it is confidential information from your company, but try to go with the minimal required config to reproduce this MRC. Can we register this acronym? And then ask for help. The community will always help, but they are also waiting for some effort here, right? So if you have the minimal required config to reproduce the issue that you're seeing, you're good to go. And I think that the community will jump to help you to troubleshoot your regular expressions or your filters or whatever. We provide community support through GitHub, Slack, and also Stack Overflow. Stack Overflow is where we receive the least, but we still go around from time to time. And in the open source community, we have community calls where you can bring your use cases, your issues, your asks. Last week, we had the first open town hall, I think it was called, with Eduardo. A lot of good ideas came from there. And I hope we can start implementing those and helping the community.